Hey y'all, you got Doug Moore, Dougie Doo here with Cajun Sawplush. I want to talk a little bit about the basics of electricity. And although this is not a GFI or a GFCI, the GFI or GFCI electrical receptacles have the little test and reset button in there. What it stands for is ground fault circuit interrupter. They used to be called the GFI, now they're called the GFCI. Anyhow, they work the same as having an internal breaker on the receptacle. Okay, but I had somebody call me and ask me a question about basically about electricity. So what I want to do is I want to just kind of give you a very brief overview of electricity. And for those of you that know it, this is going to be a boring video for you. Those of you that don't understand electricity and how it flows, and how it works with a GFCI and how it works with a regular receptacle, I'm going to try to get into a really kind of elementary explanation of it and try to get it out there. I'm also kind of dealing with a little bit of a migraine, so I apologize. But I wanted to get this out there. So let's start with electricity, how it flows, okay? So, and what causes the breakers to trip, what causes the GFI to trip, and where's the power at after it does trip. Again, this is not a GFI, but I don't have one here with me, so I'm going to use this as my example. So let's start off with, you have three wires that come in to your, it doesn't matter theoretically if it is your main electrical service that comes in, you've got three wires, but behind there you have three basic wires that run everything, okay? You have your pointer finger, which is going to be your black wire, which is called your hot wire, okay? That's the way I'm going to explain that. That's your hot wire. So like when you get in trouble and somebody's pointing at you, that's your hot wire, okay? This is your hot wire. So you've got three wires. You got your hot wire, your neutral wire, and your ground wire, okay? Actually, it'd be hot, ground, and neutral here. So your hot wire is going to be your black wire. Your neutral or ground wire is going to be your green wire, and your neutral is going to be white, okay? These two wires, your white and your green, your neutral and your ground, they can touch all day long and nothing's ever going to happen. You can get water across them, nothing's ever going to happen. It's not until you get to that pointer finger, the one that gets you in trouble, okay? That's why I'm trying to say that the pointer finger is the one that gets you in trouble. Okay? If it touches one or both in any combination, that's the one that gets you in trouble. Okay, so now I'm going to bring this back up, okay? So as water, if you get water back behind your electrical receptacle, on this side, water can run down all the way and it's not going to do anything, okay? This is that green wire, right? That's your ground wire. This right here is your neutral wire, okay? On the other side, this is your where your black wire goes. If you ever look at an electrical receptacle, and I don't know if this is really going to show us the coloring here. I'm going to try to do this from back behind. Okay, you see how you've got the green here? That's the ground, okay? Green, ground, both start with a G. This one here is kind of a silver colored, and this here is a brass color. So the way I like to remember them or explain them is black and brass both start with a B. So if you're ever trying to wire one of these, black and brass, right? This is kind of silver or white, okay? That's where your white one goes. And then this one here is where your green one goes, and it's the ground. So again, I know this is basic elementary stuff for those of you that already know, but those of you that don't. So now, if you get water flowing down and it touches across these two, right? That's what causes the breaker to trip. That's what causes the arc, the spark, the bang, right? Okay. If you have a GFI or a GFCI, it's got the test and reset button right here, okay? If water gets behind this, it's still going to go boom, and it's going to trip the breaker. Or if it goes inside here, it's going to go boom, it's going to trip the breaker. Inside this device itself, okay, the test and reset button. If it's a receptacle like this, it's not. It should trip it back at the main breaker, okay? The purposes of the GFI, that's kind of what we're trying to explain though as well. If water gets down inside here, it trips the GFI. That does not mean that there's no power. It just means that there's no power here. But there's still power back here, okay? Or there can be, or should be. If it's this type of receptacle, then it would trip back at the breaker in the main panel, and there's no power here. That's why you might hear someone say, if you've got a GFI and it starts smoking and you're trying to put it out with water, you're just you're creating more problem because the power back here hasn't shut off, unless it happens to trip the breaker back at the main panel. Okay. So getting back to understanding what is the arcing and sparking. So when electricity flows, it generates heat, right? So let's understand breakers now. So a lot of times we talk about the breakers because of, like we're talking about a booster pump, and the booster pump might be drawing, let's say 16, 17 amps. That's not the norm, but let me boil down to how breakers work, okay? And I'm going to put it again in a very simple term. This is not how it actually is. Let's say that a breaker is rated at 15 amps, okay? Let's change that amps and call it temperature, okay? That's not the way it works, remember, but let's just call amps temperature. So that breaker is rated for 15 amps or 15 degrees, okay? The breaker, the item that you're using, let's say it's a booster pump, and that booster pump is rated for 20 amps or 20 degrees. Well, 20 is higher. So it's trying to draw too much heat through that 15 amp breaker, 15 degree breaker, and it causes the breaker to trip because there's too much electricity, too much heat being generated. Flip that vice versa. Let's say you have a 20 amp breaker and you've got a 15 amp booster. Again, talking about temperature wise. Okay, the reality is it's lower than that, and I'll get into that. But so if you have a 20 amp breaker and you have a 15 amp booster pump, 15 degrees is lower than the 20 degrees. So it shouldn't trip this breaker, okay, because that's a lower number. The reality is that a lot of these boosters are, I think, somewhere between 10 and 12 amps, and most of the outside receptacles are at 15 amps. So again, that would be 15 degrees versus 12 degrees. The 12 degrees is still lower. There is an initial kick sometimes, and that's why when you hook up two boosters to the same GFI, it'll trip back and forth. It'll go crazy. It just doesn't work that way. You're trying to draw too much heat through that receptacle. So that's kind of trying to get you to a basic understanding. So again, understanding that hot, ground, neutral, black, green, white, okay, green, white, black. Water gets through, touches them. Again, it can touch, the green and the white can touch all day long and not trip a breaker. It's only when that black pointer finger, you've been bad, gets in there that it causes an issue, okay? If you have a GFI and the GFI trips, can still mean there's power back here unless it trips back at the main breaker. One other just quick tidbit on that. A lot of times when you trip a GFI, okay, you find it somewhere else on the outside of the house. If you can't find it on the outside of the house, the odds are it's either, sometimes it'll be in the master bathroom, but it'll be in another, I'll say, wet location. So it might be in the kitchen, might be in the garage, but typically they're on a different circuit. But it could also be in the master bathroom. She comes home, she can't dry her hair, and she's not happy with you. So anyhow, I hope that's an understanding of basics of electricity and how it flows. If you have any questions, holler at me. I appreciate y'all for listening to me, and Dougie Do out.